Let's prove a property of mod with exponents, integer exponents, where we'll actually be able to use induction. We'll prove that this by induction on e. And the base case, well, let's do a few base cases. Base equals 0 would be saying that a to the 0 mod n, which equals 1, is equal to a mod n to the 0. That works. Let's look at a few more. A to the 1 mod n is certainly the same as a mod n to the 1. E equals 2, we would have a squared mod n is supposed to equal to a, well, mod n squared, and this is by what we just did, Q3. Okay, so in general, let me skip these base cases and just think about what happens for any e greater than 0. I get to assume the induction hypothesis that for all 0 less than or equal to k less than e, I already know the answer, that a to the k mod n is equal to a mod n to the k. I want to show it for e. Okay, so what if I'm given a e mod n, but that's going to be a to the times a to the e minus 1 mod n, which equals a mod n times a to the e minus 1 mod n, all taken mod n, by Q3. But now I can use the induction hypothesis here. So this is going to equal a mod n, and I can pull a mod n and take e minus 1 out here, and this is all mod n yet. This is by the induction hypothesis with k equals to e minus 1. And that is just what I wanted, a mod n to the e mod n, QED. So our final answer is mostly a matter of copying to show that for all a n not equal to 0, e greater than or equal to 0, that a to the e mod n is equal to a mod n to the e mod n by induction on e. Base case, e equals 0. I can simply a to the e mod n equals 1 equals a mod n to the e mod n. The induction step, so given some e greater than 0, I get to assume on the induction hypothesis that for all 0 less than or equal to k less than e, that what I want is known, that a to the k mod n is equal to a mod n to the k mod n. And then I want to show it for e. Well, let's look at a to the e mod n, which we can just write as a times a to the e minus 1 mod n by the definition of the exponent. But that is equal to a mod n times a to the e minus 1 mod n by the previous Q3, which is equal, just copy a mod n, and we'll apply the induction hypothesis here, which is a mod n to the e minus 1, all mod n. This is the induction hypothesis where we're using k equals to e minus 1, so it applies because it's smaller. And now multiplying out a mod n to the e mod n by definition of exponents, QED.